Hello, welcome back to our ASCPi study series. Today we are diving into a really practical questions that cover hemoglobinopathies like sickle cell, essential laboratory procedures, troubleshootings, and even a few calculations. This is the kind of material you see every in your lab and on your examination. First up, which of the following is an incorrect statement about the solubility test for hemoglobin S? You are looking for a false statement. So, answer is C. Why this statement is incorrect? The solubility test detects the presence of any cycling hemoglobin, but it cannot quantify it or distinguish between heterozygous state sickle cell trait hemoglobin AS and the homozygous state sickle cell disease hemoglobin SS. Both were produced as positive result. So question number 2. Which one does not cause a low result? Which of the following is not associated with causing a falsely low ESR? So answer is A. Column used is slanted. The question asks what does not cause falsely low ESR? The slanted column actually causes a falsely high ESR. The angle gives the result a shorter distance to fall vertically, making it seem like they fell faster than they did. A platelet is performed on an automated instrument from an EDTA blood sample. Smear evaluation reveals the presence of platelet clamps. The specimen is redrawn using sodium citrate as the anticoagulant and count 300 into 10 power 9 per liter is obtained. What is the correct platelet count to report? So correct answer is C, 330 into 10 power 9 per liter. Platelet clamps in EDTA suggest EDTA-induced pseudothrombocytopenia. The standard procedure is to redraw the sample in the light blue top sodium citrate gel. However, citrate gel have 1:9 anticoagulant to blood ratio. This dilutes the sample. You must correct for this dilution by multiplying the instrument's result by 1.1. So the calculation is your results 300 into 10 power 9 per liter multiplied with 1.1. So you must always report the corrected count 330 into 10 power 9 per liter. The next question is to best preserve cellular morphology, differential smears from an EDTA specimen should be made no more than blood hours after collection. So correct answer is B, 5 hours. This is the standard laboratory practice guideline. While making a smear as soon as possible is ideal within 2 hours, cellular morphology from an EDTA sample is generally considered acceptable up to 4 to 5 hours after collection. After these times, artifacts like vacuolated monocytes, necrotic neutrophils, and cleared RBC can begin to appear, which can interfere with that accurate differential. The blood smear made on a patient with polycythemia vera is too short. What should be done to correct this problem? The correct answer is A. Decrease the angle of the spreader slide. Polycythemia vera means the patient has very high hematocrit, so the blood is very thick. Thick blood doesn't spread easily and creates a short smear. To create a longer smear, you need to decrease the angle of the spreader slide, make it flatter. This gives the thick blood more space and time to spread out before it stops. So number 6, the components of right stain include. So answer is D, methylene blue and erosin. Red stain is a type of Romanowski stain. All Romanowski stains are based on a combination of two dyes, methylene blue, a basis dye that stain acidic cell components like DNA in the nucleus, blue or purple, and erosin, and acidic dye that stain basis components like hemoglobin in RBC, pink or red. Number 7. What is the reason for red blood cells to be bright red and the WBC nuclei to be poorly stained when using right stain? The answer is C. The stain or buffer is too acidic. This is a classic staining problem. When the stain or buffer combination is too acidic, pH less than 6.4, the acidic erosin component red dominates and the basis methylene blue component blue is inhibited. If 60 reticulocytes are counted in 1000 red blood cells, what is the reticulocyte count? So, correct answer is C, 6.0%. The formula for calculating a reticulocyte count in percent is number of reticulocyte counted is divided by to the number of RBC count multiply 100. In the case described in the question, percentage reticulocytes equals 60 divided by 1000 into 100 equals 6.0%. Because the error in reticulocyte counts is high, it is described to count a larger number of the cells or use a standardized counting method such as Miller-Diggs. Move to our last question. Using the percentage reticulocyte from question 8 and an RBC count of 3.0 into 10^12 per liter. The calculated absolute reticulocyte count reported in SI unit is C 180 into 10^9 per liter. The formula used to calculate the absolute reticulocyte count is reticulocyte percentage by 100 into RBC into 1000. Multiplication by 1000 is 10 to report the results in SI units of 10^9 per liter. In this case, the percentage of reticulocyte from question number 8 is 6.0. So 6.0 into our RBC count 3.0 divided by 100 and multiply with 1000. So the result is 180 into 10^9 per liter. I hope you learned something new. See you in the next video.